All right, we're going to be talking about Chapter 8 now. This is going to be our last chapter of the semester. We're going to be talking about functions, systems of equations, inequalities, different things dealing with coordinate systems. So we're going to talk about, first of all, today we're going to talk about the rectangular coordinate system and circles. We're going to be talking about lines and slopes and average rate of change. We're going to be talking about equations of lines and models of lines. We're going to talk a little bit about functions, not a whole lot. Now, as I emailed y'all earlier, anything dealing with the quadratics and the exponentials we're not going to do, so we're not going to look at section 8.5 and 8.6. We're going to look at section 8.7, which is talking about systems of equations. We're going to look a little bit at section 8, which is talking about applications, and then we're going to talk about systems of linear equations and linear programming. So we're just going to do a little bit on those last two sections just so you are familiar with the process. So today we're going to look at rectangular coordinate system and circles. We're going to talk about rectangular coordinates, distance formula, midpoint formula, and circles, and the formula for circles. So with rectangular coordinates, the first thing, probably the most important thing that we're going to deal with is the concept of an ordered pair. And an ordered pair is a set of points or a set of numbers that is written in this particular format that tells us where we want to put a point or where we're looking at on the graph. So it's always written in this format with the parentheses and the comma between them. The two numbers are called components of the ordered pair. The first number in the ordered pair always represents the x-axis of the coordinate system, and the second number always represents the y-axis of the coordinate system. So what we're doing is we're looking at where the two lines intersect. If I follow the x line at 3 and the y line at 2, we're looking to see where those 2 points intersect. So this is what a rectangular coordinate system looks like. Typically, it's called a Cartesian coordinate system. There are a number of components. The y-axis is the line that is through the middle of the graph, and it goes vertically. The x-axis is the line that goes horizontally through the middle of the graph. In our system, we're always going to be talking about those two pieces going through the middle of the graph, although there are other examples where you may see the x-axis and the y-axis and only part of the graph being shown. Where the x-axis and the y-axis intersect is called the origin, and the origin always has the coordinate value of 0, 0. So this is the origin. The quadrants are these areas of the Cartesian coordinate system that have been split up. There are 4 quadrants or 4 areas. The areas are numbered counterclockwise starting in the top right hand corner. So this top quadrant is quadrant 1, quadrant 2 is over here to the left, quadrant 3 is below it, and quadrant 4 is below that. So a lot of times if you think about the letter C, the letter C defines how you label your quadrants. You can hopefully remember that because it's talking about coordinates or it's talking about Cartesian, whichever way you want to remember it. And it's important to keep that in mind of what the quadrants are and where they are. So if we go back to that example that we had a second ago, and I wanted you to graph the point or plot the point 3, 2. So that's telling you that x is 3 and y is 2. So here's our x-axis. This is 0. This is 1, 2, 3. So there's my 3. Y is 2. Y is 2. Now if I take those two lines and I draw them until they intersect, where they intersect, right here, that's the ordered pair 3, 2. So when you graph an ordered pair, the only thing that you should be graphing is the final result where they intersect. So if you look at my example here, this blue dot is the coordinate 3, 2. So let's do another one. Let's say I wanted to do -2, +4. So that means x is -2 and y is +4. So x is -2 would be right here. Y is +4 would be up here. And where those two lines intersect is up here in the top. So this point, this blue dot again, is the point -2, +4. So here's some other examples of points that have been plotted. We just did 3, 2. Some of the ones that tend to mess people up the most are, for example, the 0, 1 that you see here. Remember, x is 0, y is 1. So you're going to go where x is 0, you're going to go where y is 1, and you're going to draw until those two lines intersect. But on the second example here, we have x is -3, y is 0. So we're going to go where x is -3 and y is 0, and that's where the 2 points intersect. So it's extremely important to remember that when you have a coordinate or an ordered pair, that the first number in the first component is always x, and the second number is always y. So using those coordinates, we can figure out how far apart the 2 points are. And there's a formula that we use for that. So what you have to remember is that you're going to be given 2 points. For example, if I gave you 1, 2, and put a little mark below it. If I gave you the point 1, 2, and over here I gave you the point -3, 5, and I said find the distance between those 2 points. So what you have to remember is that we have a graph. Here's my x, here's my y. +1, +2 would be +1, +2. So there's my first point. -3, +5 would be -3. And I'm just estimating these values. +5 would be up here. So I'm asking you to find out how far apart are those 2 points. That's what the distance formula is telling me. How far apart are those 2 points? So to do this, we're going to do this formula. The distance is the square root, that's what the symbol is, the square root of x2 minus x1. So this is going to be my first x, so this is x1, and this one's x2. And this is my first y, so this is y1, and this is y2. So this is not saying square the x or something like that. It's saying it's the first x and the second x and the first y and the second y. That's all that's referring to. So we're going to subtract those 2 x's, subtract the 2 y's, we're going to square them, and we're going to figure out the distance. So let's look at an example. I want you to find the distance between 1, -2, and 5, 7. So it doesn't matter which one you call x1 and which one you call x2. I'm going to call this one x1 since it's the first one listed. This is y1, this is x2, and this is y2. So using our formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Put in my numbers. So x2 is 5 minus 1 squared plus 7 minus -2 squared. So if we do the math, 5 minus 1 is 4. So you get 4 squared plus 7 minus a negative would be 7 plus 2. So this is going to be 9 squared. So we end up with 16 plus 81, which equals the square root of 97. If we put that in our calculator, it's approximately 9.84. This is about 9.84. So what that tells us is that the distance between the point, think about our graphs again if that helps a little bit, the distance between the point 1, -2, and +5, +7, okay? So the distance between those 2 points is about 9.84. Now we don't know whether it's centimeters or inches or feet or whatever the case is, so we're just going to say 9.84, but it could be, we're just going to say 9.84 units. All right, so another formula we're going to look at is midpoint, and midpoint is just that. It's the point that is in the middle of the segment. It's the same distance from both ends of the segment. Now the formula that we're going to use for midpoint, again, we're going to use the x1 and y1 and x2 and y2. And so what we're going to do is we're going to say the midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So what we're trying to do is figure out where is the point in the middle. So this is very, very important. We're looking for the point in the middle. So notice that your answer is in the form x, comma, y. So you have to have the parentheses in your answers and the comma in between. So the x and the y that you get for these answers are the middle point between the 2 points that you started with. Okay, so here's an example. Again, same problems that we had a second ago, but this time we're looking for midpoint. So let's just do a quick graph and just get a better idea. So the point 1, -2 is right here, and the point 5, 7, lines. Okay, so the point 5, 7 is up here. Okay, and if I look at this line segment, the point in the middle is approximately right there. So that's what we're going to do. We're going to calculate what is the value of that point. So if we look at this, it's about over 3, up a little bit around 2, maybe over a little bit less than 3. So we're just estimating. If you had a piece of graph paper, you could probably get a better idea. But we're going to figure out what this is. But right now we're estimating it to be about, we're estimating this to be about 3, 2, something like that. Over 3, up to maybe a little bit more or less than that. So again, here's our formula. This is x1, y1, x2, y2, and again, it'll work either way, no matter how you set it up. So we're going to do x1 plus x2, so 1 plus 5 divided by 2, comma, -2 plus 7 divided by 2. We're looking for an ordered pair. Now it's very, very important when you put this in your calculator, you have to calculate the numerator first and then divide by 2. So 1 plus 5 is 6 divided by 2. -2 plus 7, remember positives and negatives they subtract, is 5 divided by 2. So if I simplify these fractions a little bit, 6 divided by 2 is 3, and 5 divided by 2 is 2.5. So this is my midpoint. Now remember, we estimated the midpoint's about 3, 2. So we're right on target. The midpoint is over 3 up 2.5, so it's a little bit higher than 2. And that is the midpoint of these 2 segments, and these 2 points. And remember again, your answer has to be written in the form of a point, an ordered pair, with the comma in between and the parentheses. All right, so now with circles, what we're going to look at with circles is circles are a set of points in a plane that are always equal distance from a fixed point. So if I give you any point and I tell you that I want all the numbers that are 3 away from that point. I could go 3 this way. I could go 3 up. Draw a better line. I could go 3 to the left, and I could go 3 down. Well, technically, I could go 3 in this direction, and 3 in this direction, and 3 in this direction. So the set of points that are 3 units away from that point here in the middle is considered the circle. It's all those points that are on that blue line. The fixed point is called the center, and the distance away is called the radius. So here's an equation of a circle, and what we're looking at here is, if I were to give you this information, you should be able to take this equation and calculate the center and the radius, or be able to graph an equation. So just to give you, a little bit better idea, when we were looking at a previous material, we talked about lines, and a line equals y equals mx plus b. And when we're talking about lines, or actually we haven't really talked about that yet, so we'll come back to that. So what this is going to tell us is, given a problem in this format, we're going to be able to figure out what the center of the circle is and what the radius of the circle is. If the center of the circle is at the origin, remember the origin is 0, 0. If I were to take 0, 0 and plug it in for h and k, okay, so what is x minus 0? It should be x. And y minus 0 is y. And so if I were to say that the center is at the origin, then this is the format of the formula for a circle. If the center is not at the origin, if it's at any other point, then your formula will look like this, where you have a binomial, or you have 2 terms inside the parentheses. So here's an example. Find the equation for the center, for the circle with the center at 2, -5, and the radius at 4. So here's our formula again: x minus h squared plus y minus k squared equals r squared. If you ever have any doubt about which one's h and which one's k, h is the one that's in the x position, and k is the one in the y position. So this is h, this is k. We're going to plug those numbers in. So x minus 2, y minus -5, and then the r, the radius, is 4, so we're going to plug that in, 4 squared. Now if we clean this up a little bit, your 2 negatives become positive, so I can't clean up the first part any because I can't combine like terms, so I end up with my formula being x minus 2 squared plus y plus 5 squared, equals 16. And so that's the formula for a circle with a center at the point 2, -5, and a radius at 4. Okay, so one of the things that I want you to pay attention to here is, remember that this is the h value, or the x value, this is the k value, and this value is r squared. So when I'm trying to figure out what h is in the problem, I'm always going to do the opposite of this. Since it's -2, h is +2. Since this is +5, then k is -5. And r squared equals 16, so remember, to solve that problem, r equals the square root of 16, which is 4. Okay, so now let's look at this next example. Now this time, I gave the answer already, so I cheated. This time, I gave you the equation of the circle, and I want you to figure out the center and the radius, and then graph it. So if we look at this, remember what we talked about. This is the h, this is the k, and this is r squared. So remember what I told you to do is take this part of the problem and do the opposite of it. So h is -1. Take this part here and do the opposite of it. So k is +2. R squared equals 9. So r equals the square root of 9, which is 3. So our center is at -1, +2, because remember again, the center is at hk, and the radius is 3. Now if I want you to graph that, what I'm going to do is I'm going to tell you to go on your graph to the point -1, +2, because that's our center, and we're going to put a dot for the center. And then from that center, we're going to go up 3 spots. So we're going to go up 3 points. We're going to go back to the center. We're going to go down 3. 1, 2, 3. So that's about 3. We're going to go to the right 3. So 1, 2, 3. So that's about 3 to the right. And we're going to go to the left 3. 1, 2, 3. So that's about 3 to the left. When we connect those red dots together, we have the picture of the circle. This is the formula for the equation of the circle. This is the center of the circle, the radius of the circle, and this is what the picture looks like. And that's what you see on this slide. We went to the point -1, +2. We went up 3 spots, and we had to estimate a little bit because we ran off the graph. We went down 3 spots from the center. We went to the right 3 spots. And we went to the left 3 spots. And then we took those 4 points that we had, just 4 points back on there. We're going to take those 4 points that we had, and when we connect them together, we have the picture of the circle. So I hope this helps. Keep in touch. We're in the end of the class. Make sure you keep up with the class and don't get behind. And let me know if you're having any problems or need help. Have a great week.